Okay, so welcome all of you. The summer school, as you have seen, is let's say a 2 week session, which starts today with our keynote speeches. So after our first introduction today, we will have a short introduction to frontiers by Professor Margaret Farr and me. Then we will proceed to the frontiers pedagogical design, and then we will have some thematic keynote speeches by experts on the respective fields in order to introduce the science case that will be later on following in doing educational activities based on them. So we have high energy physics by Professor Christine Kourkoumelis. We will have frontiers in astrophysics and cosmology by Dr. Rosa Doran. We will have neutrino astronomy by Dr. Sophocles Sotiriou, and we will have gravitational wave astronomy by Professor Stavros Katsanevas. After a short break then, we will have a remote visit at 1:30 CET to the Virgo gravitational wave detector and until 2 o'clock CET. And this summarizes the first day. After the end of the first day, you will all receive a Google form in which we will ask you to fill the groups that you prefer to participate in. Because from the second day and on, we will be dividing our work in modules. Every module will have a subject orientation, for example, high energy physics or gravitational wave astronomy. And after discussing with you the educational content that we have produced in this one, we will proceed in forming a working group, which will include some of you and some of us, to cooperate and design to co-create our own activities. So you will be asked to fill a Google form that you prefer. And I think this is it from me. Maybe, I don't know, Maria Luisa, would you like to say something?
No, I think you have already said it all very clearly.
Okay.
Thank you.
Okay, so in order to start rolling, I will share my screen to give you an overview of Frontiers project for the next 10 to 15 minutes. Okay. So I share my screen. Can you see my screen?
Yeah.
Okay, I will stop my camera. Okay. So, Frontiers, bringing Nobel Prize Physics to the classroom. Frontiers, the name Frontiers comes from the fact that fundamental research in physics right now has, so to say, three big frontiers. The first one is the energy frontier. It is the module that you will be exploring with Professor Kourkoumelis, which describes the attempt of physicists to unravel the mysteries of the universe by colliding protons in very high energies at CERN. The second frontier is the intensity frontier, in which we are searching for very rare phenomena through the collision of particles with beams of very high intensity. The third frontier is the cosmic frontier, in which by deciphering signals from the cosmos in terms of gravitational waves, of astrophysical probes such as optical astronomy, gamma ray astronomy, and neutrinos, we are trying to figure out our cosmos. All these frontiers have produced game-changing discoveries which have great media coverage and have produced great Nobel Prizes. For example, the Higgs discovery of the Higgs boson offered the Nobel Prize in 2013, the discovery of gravitational waves, the Nobel Prize of 2017. And these discoveries have an unprecedented impact in humankind. For example, the World Wide Web was initiated at CERN in order to help scientists share their data among them. But if you search CERN on YouTube, if you do this short exercise, of course, I think YouTube has changed a little bit its regulations now, you will see that we have videos like this saying what darkness does CERN hope to unleash, or what CERN scientists won't tell you, and we have done something we shouldn't, all these conspiracy theories. And of course, if you would like to go one step further, you might see, for example, that flat earthers have a conference also. So we believe that everything starts from education. And quoting Sin Carroll here, every high school student should be exposed to the basic qualitative, at least, ideas of modern physics. We all know that 20th century physics is not systematically integrated in the K-12 formal education and in school curricula. Of course, there are some exceptions, but the norm is that it isn't. And generally, as teachers, don't really feel confident to address students' questions regarding these issues. There have been many education and outreach initiatives, especially in high-energy physics and astronomy, such as the particle physics master classes, which have documented impact in many countries. Okay, and from the analysis of student data, we see that we have students like this, and of course, these have the potential to change students' vision of science and scientists. This comes, for example, from from a visit of students to Fermilab, to the Fermi National Laboratory in the USA. They asked them to draw a scientist before they joined and after they did. So before, they describe a scientist as a mad scientist with hair standing straight up and so on. And after that, they said that scientists love their jobs, they wake up in the morning and are excited to come to work, and so on. So you see that even a small glimpse of how a modern scientist look like can help students, come closer to what is really happening. Modern physics, we will more or less refer to it as Nobel Prize physics or frontier physics, has the potential to attract students to science careers. This comes from an old research done in UK in college students, and they interviewed these people and asked them, why did you select to become a physicist? And most answers have the common ground that the teachers or the school classes inspired them. And the topics that seemed to inspire them more to do this were relativity, gravitation, astrophysics, elementary particles. Teachers who have participated in initiatives such as the master classes and so on, they say that there are too many topics, the time is very short, we have lack of time, and these are things that more or less all of us know so far. But they also stated that they had no idea about the possibilities, there are new methods, and so on. So in this framework, we can identify a series of challenges regarding teacher training in frontier science. First of all, the lack of organized training materials. We don't have so far many teachers properly trained in modern science. And of course, the problem that almost everyone faces is the lack of active classroom time, which comes due to curriculum inflexibility. So, what is Frontiers doing? Frontiers is a project funded by the Erasmus Plus framework of the European Union, which ends in 2021, and it aims to address these challenges of introducing frontier physics to the classroom. How? First of all, we have aggregated a team of experts coming from scientific research, from science education, and from teacher training networks and astrophysics outreach. We have investigated already existent outreach practices, and we have drawn some conclusions from them. We have learned our lesson, so to say. And out of this, by adopting the inquiry-based science education pedagogy, which Margaret will describe a bit later, so I will go through quickly, we have developed educational content, the so-called frontiers demonstrators, which are cutting-edge educational activities ready for your classroom. This is what we will be investigating in the fields of high-energy physics, gravitational wave astronomy, astrophysics, astroparticle physics. All these activities follow the inquiry-based science education approach. They embed virtually science applications, and we also have assessment within them if you want to use them. Furthermore, as we do now, that we bring everyone together who is interested to investigate further and contribute in this attempt, we develop national and international communities of practice for educators. We have developed this where we can upload our content, share feedback, discuss among ourselves. We have one for every country, and we have a central one. We also have the Google Classroom, and we also have our dissemination Facebook channels. And we also offer continuous training and support for the implementation of these frontiers activities in the classroom, like we are doing now. So, since this is not if, this is a since you believe that it is worthwhile to do this, you are here after all with us, and you want to become part, we invite you to join us. You can have all our channels here. We will share with you the presentation for the Facebook group, for everything that we have. Okay, you will be able to receive continuous support, and hopefully by working together, we will be able to do beautiful things for our students. So thank you very much. This was my introduction.